Hey guys, so recently I started posting pictures and videos on my Instagram about the truck build that I'm starting. So what I wanted to do is maybe put a video together here for like my YouTube channel, just for people to see what's going on, what I'm working on, and how this all started. The truck in question is sitting right here. So this is a 1992 C1500 regular cab long bed. So this truck I got from my grandfather when he passed away 1 decade ago this year, actually this November. The truck, when I first got it, was in real rough shape. It had, cab corners needed replaced, rockers needed replaced. And at the time I was about 19 years old and started working on the truck then. Right now we just have it in my garage. When I got the truck, it had a 4.3 liter in it, little V6, and I got this 350 HO small block crate motor from my friend who also had a C10 pickup truck that it was in, and of course we needed to hop it up. So it's a full roller motor, Vortec heads, it's like your basic Vortec build with like screw-in studs, carbureted HEI distributor, and probably too big of a cam. It's got an XR282 camshaft and RPM air gap intake from Edelbrock. So it's a good runner. It's probably like a 450 horse motor with the full headers and stuff like that, full length headers. And overall it was a ripper, but it's not really what I wanted to do. So the truck's been sitting out for about 3 years, and as you can see, it's been collecting crap sitting in it, but it's still a 6-shift car. It's bench seat, the whole 9 yards. What I want to do is we're going to start turning this truck into something. So the goal of this project is to turn this C1500 pickup truck for more than just a little hot rodded pickup into something a little bit more purpose built. My goal with this truck is to turn it into sort of a pro touring style build slash track day truck for autocross and track events. So if you don't know anything about C1500 OBS trucks like this one, they're not yet that popular. They're catching on, but they're not like the C10 trucks and stuff like that have really taken off. So there's not a ton of aftermarket support as far as full chassis and things like that. So that's where this comes in. This project is to build a full chassis for this truck, convert it over to a short bed truck. It's really not even a short bed. It's gonna have short bed sides on it, but all the bed structure under here, it's gonna be gone. With the frame and stuff like that, replacement, it's not gonna be necessarily much of a truck. For truck duty, it's going to be as rowdy as I can make it. So I guess we'll show you where we start next. I've been working now for about 8 months on getting my shop sort of tuned up for what I want to do here. So got the drill press running, got a little horizontal bandsaw. This section in here, I built this CNC plasma table, which if you follow my Instagram, you've probably been seeing things being worked on there. In here, I have a general little fabrication area where I have a steel rack, a bender over there, hydraulic bender, and an alpha TIG set up with a fabrication table. So this is basically the setup of where I'm going to be doing most of this work. And then in this middle bay, I'm going to clean this all out, move that CNC plasma table over to the fab area, and we're going to build a frame table in here. And that's where we're going to do the majority of our work. As you can see here, which we'll go over in this episode of the build, we're going to be talking about how I built this front crossmember for the truck. And then we'll talk about where we're going next. So what you see here is actually my CAD design for the front crossmember. The rest of the frame in the CAD model is hidden, but this is made up of a couple pieces. You have a front piece, some cover plates, a recessed section there for where the oil pan will recess into,
as well as some reinforcement tabs, which are those little slotted portions on the front. And then you can see the lower control arm tubes that are inserted through the crossmember, and those serve as basically guides for the lower control arm shafts. So next we're going to show you how this thing was cut out.
What we're doing is we'll just get this material topped off here with water, probably get it within a 1/4 inch of the back of the plate, and then we're going to cut the cross members out, just the vertical portions of the cross member, and then after that we're going to go in and nest in the other components. Unfortunately, I only have the trial version right now on the sheet cam software, so I can't do all of it at once, so I'll have to sort of manually nest it, and we'll go from there. Okay guys, so we have everything loaded up and we have the material on the table, everything's zeroed out. I am not going to run my THC control, I have it in manual mode, and I'm not going to do touch-offs. I'm having difficulty with the machine. When it's running, it's causing issues where the plasma, the THC and the voltage connection and the plasma just isn't working that well, so I need to address some things there. But for the thickness of this material, I'm pretty sure I can get a good cut. So you may see me holding my calibrated stick. This is to push down the material in case anything starts to warp up a little bit. So let's give this a shot.
Okay guys, so while the plasma cutter's cutting out this front cross member components, I figured I'd touch on the actual plasma cutter for a minute. The plasma cutter I built for over the last 6 months off and on. I was sort of busy. I bought a house, moved my garage, had a baby, a lot of things going on in that 6 months. So I didn't have a whole lot of time to work on it, but when I did, I tried to work on making it as nice as I could. And I kind of used it as a trial run for the fabrication on my truck. I figured if I could fabricate this neatly and cleanly, then I could use this project to hone my skills of fabrication and learn how to do a little bit better job than what I did before. So just to give you a little bit of background, I am not a skilled fabricator by any stretch of the imagination. I just started TIG welding about 1 year ago. It was the first piece of equipment I bought. And then pretty much immediately after I built my fabrication table, went right into building this. I am a mechanical engineer by trade, but this is still a little bit out of my comfort level. As far as the actual machine goes, all the metal components were fabricated by me. The electronic components, as far as the motion controller, the drivers, the power supply, all those type components, they were purchased from a company called Pokies. Or PoLabs, and it is a great motion controller because it's Ethernet. Ethernet capability has a really nice, robust data transfer, and with plasma cutting, you have a lot of electrical noise that you might have to worry about. So having a robust method of communication with your laptop is critical. With regards to the actual controls, I'm using Mach 4 to do my motion control, and my cam software is Sheet Cam, which I really like. It's set up to run plasma, so it can add all these little extra corner reliefs and other information right into the G code, which is great. The plasma machine itself is a great cutting machine, has great duty cycle and power. It's an Everlast 80S with the CNC port. The only complaint with the Everlast is that the voltage that comes out of the machine is sort of erratic when you're looking at it on the CNC output, and that causes problems when you're trying to run a torch-like controller. So these cuts here, I'm not running a torch-like controller, but ideally you would, because a torch-like controller accounts for any warpage during your cut and guarantees that you have a consistent height over the material when you're cutting. And that just gives you a better finish. This, fortunately, was great. I had a great finish with it. And as you can see here, the parts were very nice.
There you go.
So this is the finished product of the plasma cutting. Just need to bend up these top cover plates in the oil pan recess. You can see everything in here. Nice snaps together. There's keys everywhere to lock it into place and make the fit up a little bit easier. And overall, I'm pretty happy. Okay guys, so what we're gonna do today is I'm gonna get this bottom panel bent up to these Crossmember pieces here. So I got all acetoned off and cleaned up, and we're gonna mark out our bend lines and see how close we can get this going. Haven't really done a whole lot of work yet with this Swag Off-Road press brake, but hopefully we can get our dimensions pretty close. I have this little dial indicator or angle indicator here, magnetic angle indicator, and we'll use this and the drawings to see how accurate we can get and how tight we can get on our gaps and fit up for this here Crossmember. See what happens. So somehow I managed not to be able to record that because my camera didn't record, but this is the first attempt of the bend. We got it pretty lined up on the bend line there, and when we check it, it looks like we got it pretty close. Yeah, it's showing up 45 degrees, which is awesome. So I actually had to bend to 46 degrees in the press, and I got about 1 degree of spring back, so that's pretty good. So then we'll try to do this side next, and then we'll do an overall fit up and see how she looks. So let me show you guys why this angle cube is worth the 30 or 40 bucks if you decide on getting it. So when you buy the Swag Off-Road finger brake, you can buy this. It's an angle cube. I'm sure it's Chinese made, but it's pretty heavy duty. It's magnetic, and you can zero it out on your one side. So one thing, when you're bending this plate, it never bends even. You can see that this end's sticking way up, this end's over here, and it makes it hard to gauge how far you bent. So this angle cube, you zero it out on one side, you can bring it over to the other side, click it on, and you can see, okay, I'm a couple degrees short. So I'm gonna take a real short stroke here, and I'm gonna come up probably about half the distance I am away. So it didn't move much there, but I felt the other side move. So that's why you gotta check it each time. So bring it over here. This side's moved a little bit. Let's go a little bit more. Okay, so that moved a lot, well, actually more than I wanted. But let's zero it out there for a check. So you're zeroed here good, and then you can check the comparison on this side. And we're 45.35. So what I'm gonna do is just go ever so slightly past that, because we get a little bit of spring back. The last piece got about 1 degree of spring back. We should be really close now. Let's get on the stiffer part here. Zero. And over here, 46. That's just about perfect. So we'll go ahead and take this out and fit it up and see how close we are. Okay, so we got our first problem already. So when I fit this up and I measured it, if you look at this side, I put it on that side of the plate, I have a nice, about 45 degree angle, okay? When I set the material up, there's a gap on this side. I'm thinking, oh, that's weird. When you check this side, here, I have a 44 degree angle. So I have a 1 degree less angle on this side than I do on this side, meaning that this piece is bowed very slightly, I'm exaggerating, like this. So if you look at the bend line, it's straight within the mark. So what I think is happening is I must not have been perfectly centered up in this ram. So like I said, this is like the first time I've used this thing. It's probably not the best stuff to practice on, but it's also the first time I've tried to bend anything with this amount of width. So we're learning as we go. I think what I can do for this piece is it's definitely still good to go, salvageable. I wouldn't even say salvageable, it's just fit up issue. But when I go to weld this, I'll just have to pull that corner up and tack it. and then we should be in pretty good shape still. But generally speaking, pretty good gaps there, nothing too crazy. I'm not gonna have to feed a ton of wire into it and close it off. But good first try, and we'll just have to refine our method here a little bit as we go forward, seeing if we can get these to sort of square up while they're bending. But so far so good. I really wish this had like a tighter telescoping rail there that would keep this from sort of twisting side to side. And I think a lot of this issue would go away. But that's kind of what happens when you're using cheaper tools. I mean, this isn't it's like a $400 brake, so it's not anything too expensive. So we'll go inside here, get some dinner with the wife, and then come back and try to bend the rest of these up and see what else we can get done.
5 minutes later.
All right, so we're back from dinner and back to our feature presentation. I'm gonna go ahead, get this all up, find that bend line, get it all traced out on here, get that bent up. I don't even know what angle this is. I think it's 15 degrees. I need to measure it. But yeah, so we're gonna work on that now, and we'll just go ahead and plow through that and see if we can get this going, and we should be all set. Okay, so what we got going on here is not too bad. We got this bottom corner here just had to round out a little bit, and this is the one bend that's open just a little bit. If you look, I can flex that. It's hard to do it with the camera in your hand, but I can flex that shut. Now this upper bend here is supposed to be a 30-degree bend. It's about 31 degrees. So what I'll do is I'll get this all sort of lined up, and I'll tack it in the center and tack a corner. And then I might just give it some gentle persuasion here. And if I tap that corner in, this will kick back out. And then it'll act like its own little anvil, bringing that piece in. This side over here is pretty good down at the bottom, but you notice I brought this upper edge in too far. I overshot about 1.5 degrees. Didn't spring back as much as I thought I was going to, so still learning, but at least now what I've noticed is the gaps on both sides are pretty even. So that's pretty good. So at least I got the angle thing figured out, because I went ahead and marked the center and put the width of the material in there so I have something to line up against. So I think the next step here is we're gonna go ahead and lay this out and just give it a couple tacks and see if we can close all the gaps up and get it sort of straightened out. Okay, so this is why having a CNC plasma is great. So we're centered up on part centers. We just tacked in the keyed components here, and I turned down the tunes, and you can see everything fits up nice and tight. We got a half open gap here. So this is the way these keys are set up. When they index in, there's half the material thickness protruding out. So got a real nice fit up here. This here, we're gonna tap in on the corners. We can draw that in nice and easy. But we'll just tack, 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 work our way out, pull this corner in, tack and tack, and then we'll flip it and work around to the other side. Before we do any real serious welding on this, we're gonna tack it down to the table and make sure that we build some tie clamps and stuff like that and suck it down to the fixture bench. And then we'll get to the real heat into it. But right now it's all about just getting it sort of laid out and boxed up. Okay, so next day, guys, we got a little bit of stuff done without off camera. I went ahead and bent the oil pan up, and this is like the oil pan clearance. So an LS is gonna fit right up in here, and there's a slight rake, and I can hold a pretty tight clearance. If it wasn't for this, I'd have to raise the engine about 1.5 inches unnecessarily to clear anything else. It just has to clear this crossmember to the tightest point. So this gives us about 1 inch of extra clearance to push the pan down and basically try to lower that center of gravity. So we're doing this in a truck build, and since we're trying to get this thing to handle, we're gonna wanna try to get the center of gravity back and also get the center of gravity as down as far as it can. So the next part I'm working on are the side plates that go right there, and I have those all marked up. But I got the first bend done here, which is an 85-degree opposite bend, and now we're going to go ahead and start working on these opposing bends and see what we can get going. So this is why having a CNC machine is legit. This is a 1-to-1 print. This is my part, and if you look at that, I can just see the black border of the print all the way around. It's damn near perfect, and I can just trace those bend lines right onto it. I'm not even going to measure it out. Just scribe and go.
All right, guys, so I was able to get both these cover plates bent out real nice, good tight fit, and then I went ahead and seam welded the entire cross member together. The cross member came out great as far as the main seam welding. Didn't warp the plates at all. I mean, everything was within probably 0.2 of a degree parallel and square to each other, which is about all you're going to get on something like this. So really happy with everything. Next week we're going to go into the mounting of the steering rack, how that is laid out on the truck, and we'll go over a little bit more of the front suspension design. A lot of detail up in that design there. Takes a lot of time. So if you like the video, please go ahead and like and subscribe below. It helps us out, and hopefully have some good information here coming up for you guys in the next episode. Take care.